In today's video, we'll be covering lab number 1 of the SQL Injection module in the Web Security Academy. If you do not have an account, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. Now, I already have an account and I am logged in, so to access the Academy, I'm going to click on Academy, scroll down, and select the learning path. So go down and select the first option, which is SQL Injection. We've already covered the theory portion in the last video, so we won't be covering it again in this video. Instead, we'll jump right ahead to the first lab, which is titled SQL Injection Vulnerability in the Where clause, allowing retrieval of hidden data. Now, the way that the Academy is structured is it gives you a description of the exercise it wants you to complete and the vulnerability that it wants you to exploit. It also gives you the solution. We're not going to look at that because we're going to try to solve the solution on our own. And then it gives you access to the lab environment to run the exploit. Before we go ahead and look at the vulnerable application, notice that I have a text document on the right, and the reason I keep one is because I'm trying to train myself to always keep notes when it comes to pen testing engagements, and so we'll be doing that in the videos as well. So let's look at the description. This lab contains a SQL injection vulnerability in the product category filter. So that's important, SQL injection vulnerability, and it's in the product category filter. When the user selects a category, the application carries out a SQL query like the following. So it actually gives us the backend SQL query that gets executed, which is great because we know the structure of the query. That means we know how to automatically build our SQL payload, and we'll see that in a bit. And then to solve the lab, perform a SQL injection attack that causes the application to display details of all products in any category, both released and unreleased. So the end goal is to display all products, regardless of the category, both released and unreleased. So what's likely happening is that the application displays the released products to the user. However, there are unreleased products that are not displayed to the public. And what we're going to try to do is exploit the SQL injection vulnerability and display the unreleased products. So let's click on the link over here. It's a shopping application, and you could refine what you see depending on category. So there is 1, 2, 3, 4. 1, 2, 3 times 4, so 12 products that you could buy. However, if you refine your search to, for example, just pets, it'll display 3 products which are somehow related to pets. And if you look at the URL over here, you'll see that the category that you selected gets populated in a parameter in the URL called category. So this is the category filter that has a SQL injection vulnerability. So this is the one that we need to exploit. Now, you might be wondering, well, in a real pen testing engagement, you're not given which parameter is exploitable. So how would you know? And the answer would be to follow the general methodology that you would when you're pen testing applications. So the first thing that you would do would be to map the application. And what that means is visit the application and learn how it works, learn the logic in the application, find out all the different endpoints in the application, find out all the different input vectors that could potentially talk to the backend of the application. And when you do that, you'll discover the category field. So that is an input vector that talks to the backend, because depending on the value that you give it, it'll display different results. And then once you've discovered this field, it's just a matter of fuzzing. So if you think it's talking to a backend SQL database, then you'll enter SQL characters that could potentially break the backend query. And this way, if it breaks the backend query, then depending on how the application is configured and how it's coded, it could give you different response codes. It could give you different responses of the application. It could give you errors and so on. And then depending on the response, you could infer the fact that it might be vulnerable to a SQL injection. And then once you've detected the fact that it might be vulnerable to a SQL injection, it's a matter of giving the application iteratively different payloads until you've figured out at least approximately how the SQL query works at the back end. And then this way you could build your payload and successfully exploit the SQL injection. Now, since this is a beginner video, we're already given the SQL injection, the SQL query that is happening at the backend. But even if you're not, this is easy to figure out depending on how you fuzz the application. So what's happening over here? Let's have an analysis section. When you entered pets, what's happening is it puts pets in the category field, and it runs this query. And what this query does is it says, select all the rows from the products table where the category column is equal to pets and the released column is equal to 1. So what it'll show you is all the products that are in the category pets, but also they have to be products that have been released. So if released was equal to, for example, 0, then you wouldn't see the product over here because it's not released to the public. So now, remember when I said fuzzing? Let's try a common SQL character that if the application doesn't properly validate user input and doesn't use parameterized queries, then chances are it is vulnerable to SQL injection. And a way to detect that is to add SQL characters that might break the query. And one of the most used ones is the quote character or the double quote character. So let's try that and see what happens. Okay, so we get an internal server error. So right away, I'm thinking this is vulnerable to a SQL injection. And the reason I think that way is because what's happening at the back end is this. Instead of having pets over here, we entered a single quote. And so it broke the application because the way it sees it is select all the rows from the products table where the category field is equal to nothing. So this quote over here that we added closed the other quote for the category field. And then all of a sudden, it has a single quote that likely resulted in a syntax error, which resulted in an error in the web server, an internal server error in the web server. And so we broke the application. So this is an indication that it's vulnerable to SQL injection. We don't know yet that it is. So let's try to build a SQL injection payload to confirm our suspicions. And to do that, I need the application to respond properly instead of responding with an error. So what I'm going to do is this quote over here that I added, it closes this quote over here. And so I'm going to add the comment field in order to tell it to ignore the rest of the query. And this way it won't run into this single quote and it won't generate an error. So let's put that payload over here. And before I run it, what would happen at the backend right now is it'll literally just run this query over here. So select all rows from the products table where the category is equal to nothing. And then because this is a comment field, it'll ignore the rest of the query. And this is a valid query, so it shouldn't give me an error. Let's run it. And here we go. So we don't get an error. We also don't get any search results because the category field is set to nothing. So it works now. I'm confident that it is vulnerable to a SQL injection vulnerability. And so the next thing to do is to try to solve the exercise. So we said the end goal of the exercise is to display all the products, both released and unreleased. So let's copy our query again and try to solve this exercise. Okay, so I needed to display all the products, so I'm going to add an OR. 1 is equal to 1, so a conditional statement. So what this will do is it'll say select all the rows from the products table where category is equal to, where either category is equal to nothing or the conditional statement 1 is equal to 1 evaluates to true. Now, 1 is equal to 1 will always evaluate to true, and so it will display all the rows in the products table. So let's try that out. This is our query over here. Sorry, our SQL injection payload. and hit enter. And here we go. It says, congratulations, you've solved the lab. If we go down, you can see that we can see 1, 2, 3, 4, 1, 2, 3, 4, 5. So that's 5 times 4, 20 entries, whereas before we were only able to see 12. And if we look at the entries, if we go back and just select gifts, for example, sorry, we select all. These are the entries that we could normally see. So safety first, folding gadgets, and so on. But then when we exploited the vulnerability, let's do that again. We're able to see much more vulnerable, products. I believe roulette drinking game was not one of them, and so on. Anyways, so we've successfully exploited the SQL injection vulnerability manually. Now let's try to script it. Okay, so if you haven't watched my introductory video on this, the reason I script the attacks is because in your pen testing career, you will run into scenarios where doing things manually is not going to cut it and is a bit unrealistic. And so as a way of training myself, I script all my attacks. And this way, when I do come across a vulnerability that requires scripting, like a blind SQL injection vulnerability, which we'll do in the future, I already know how to do it. And my language of choice is Python. So let's start doing that. So the first thing that I do is import the requests library. This will allow you to make HTTP requests and will be your best friend when it comes to web application pen testing. Next, I'll import the sys library and the URL lib3 library. What I also do is I usually set the proxy setting in all my scripts. Most people don't do that, and I don't understand why, because it's a great way of debugging why your script doesn't work, and I'll show you that in a second. Set it for 8080, and then we'll also set it for HTTPS. And so what that will do is whenever the script runs, it'll pass it through my proxy, which is burp. I'll show you that in a second. And then if I allow it in the burp proxy to relay it back to the web server, it'll do that. And then any response from the web server will get passed through my proxy again and then back to the application. So it's a great way of debugging scripts, and we'll do that in a second. And then next, I've got all my configuration settings ready. Now let's create the main method. I'm going to have a conditional statement over here. Okay, so the way that I want the script to work is when I run it, I give it two command line parameters. One is the URL of the application, and two, the payload that I want to, so the SQL injection payload that I want to use. And so it takes in two parameters. Now, if it doesn't find these two parameters, or you don't enter the correct number of parameters or so on, it'll throw an exception. And when it does that, I want it to display a nice error instead of the exception code. So let's start out with a try condition. So URL is equal to the first argument that we give it. And then the second argument would be the SQL payload. And we have an error over here. Okay. Now, if you run into an exception, then I want it to print the usage instructions, just in case the user doesn't know. So the name of the program, and then the URL, and the payload. Okay. And then I also want it to give me an example of how to run it. It's just this way the code is a little bit cleaner. And the URL is www.example.com. And let's say the payload is 1 is equal to 1. Now, because I'm using it as a string over here, I need to convert this into single quotes so that it doesn't interfere with it. Okay, awesome. And then the name of the program. And something is wrong over here. Here we go. Okay. And then exit the program since we ran into an error. Okay, awesome. All right. So if you gave it the correct command line arguments, it'll set the first one to the URL parameter, and it'll set the second command line argument to the payload. If you didn't give it the correct number of command line arguments, it'll print these statements over here. What we're going to do is we're just going to run it. Python 3 SQLI lab01.py. And here we go. So because I didn't give it the correct number of arguments, it printed the usage instructions and an example of how to run the program. Okay, up next, I want to create a function that if it evaluates to true, that means I have a SQL injection. And if it evaluates to false, that means my SQL injection, exploiting the SQL injection was not successful. So it takes in the URL and the payload. And if it evaluates to true, then it's going to print SQL injection successful. However, if it evaluates to false, it's going to print SQL injection unsuccessful. Okay, awesome. Now the next step is to create the function itself. So we'll do that over here. And again, URL payload. Now, before we fill out what the function does, so it does nothing right now, we need to learn more about the request that is happening when we click on a category. To do that, we're going to use our favorite proxy tool, which is Burp Suite. And if you don't know how to use this tool, it's definitely worth investing the time to use it, because I don't know anyone who works in the web app pen testing field that doesn't use this tool. And I'm using the community edition, so you don't have to buy the professional edition to do this. Okay, so a bit of background on what this tool does is if you configure it, what it can do is it sits as a middleman between the application and your browser. And so when I click on anything in the browser and it makes a request, it'll send it first to my proxy, which is Burp, and then it'll send it to the web server. And then when a response comes back from the web server, it'll pass it through my proxy again, and then through the web server. And the reason this is nice is because This way you could manipulate the request before it goes back to the web server. You'll see it happen with things like client-side validation and so on, but also you get to see exactly what is happening in the request, which you can technically see in the browser if you look at developer tools, but it's just so much easier to use a proxy for it. Now, I already have the proxy set at a localhost 8080, and that is why in the script you'll see over here that I set it a localhost 8080. I also need to configure my browser to use it, and so I use Foxy Proxy, which is a great extension that allows you to enter a bunch of proxy settings and then you select which one you're using. I have Burp over here. I'm going to click on options and show you how it's set. So again, I've got it set at localhost and then port 8080. Now you could do that from the proxy settings of the browser, but it just toggling it on and off becomes unrealistic to go back to your settings every time. And so it's so much easier to just turn it off and turn it on whenever you want. So let's see if this is still working. You could see over here that it intercepted the request, so it hasn't sent it back to the web server yet. Instead, it intercepted it and it tells me that this is a GET request and I'm requesting product ID 3. Now I'm going to forward the request. And it timed out, and the reason is because we haven't touched this application in a bit while we were scripting, and so we just need to load it one more time. Let's do that. And I'm going to turn the proxy off so that it doesn't intercept every single request. And you'll see over here that there are so many requests that are happening, and it'll log all of them in the HTTP history tab. And I usually like to filter on the most recent request. You see over here, that's something that you didn't see in the browser itself, that it's calling JS scripts, it's calling images, and so on. Okay, so I want to intercept what happens when I select a category, and let's go with accessories. Here we go, and I'm going to send it to repeater. Okay, so it's a GET request. I'm going to put this over here. It's a GET request, and this is the URI that it's using. So what we're going to do is we're going to turn the proxy off. We don't need it anymore. Go back to repeater, and we'll use this to build our code. Okay, so let's remove the does nothing, and then put URI is equal to filter category is equal to. Let's copy that. And then we'll make a GET request, request.get, and that would be the URL plus the URI plus the payload. So what this will do is it'll take the URL, which is https blah 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 .websecurity.net or .com, whatever it was, and then it'll concatenate the URI to it, and then it'll also concatenate the payload after the equal sign. I'm going to set verify to be equal to false and proxies to be equal to proxies. Okay. And then I want a way to figure out if the application, if we successfully exploited the vulnerability. And one way to do that is if we check if the response code has an item, so an unreleased item that is not normally viewable by the public. And so we're going to go back over here and look at all. So these are all the items that are available to the public. Now let's look at the items that are not available to the public. To do that, this is our SQL injection. Let's select a category. Okay. So I believe, if I'm not wrong, the cat grin product was not there before. So let's go back and check. it wasn't there before. So we could filter out on that payload itself. Let's do that again. Okay. So let's say if the string cat grin is in the response code r.text, then return true. That means we've successfully exploited the SQL injection vulnerability because we can see an item that we're not supposed to see as a regular user. Otherwise, return false, which means that the SQL injection vulnerability failed. So let's compile this, see if there's any errors. There are errors. And over here, save that, run it again. Okay, awesome. It looks like there's no errors. It's clear. Okay, so let's run our program. Lab 3, and then we give it the URL, which is this over here. And then the SQL injection vulnerability, which is right over here. And this is why it's good to keep notes. Space that. And that did not copyright. There we go. Okay, and let's run it, see if it was successful. Now, first of all, it is successful, which is great, but notice that we do get an error over here. And so let's try and fix that error. And to do that, it's URL lib3 dot disable warnings, URL lib3 dot exceptions dot insecure request warning. Okay. So now it shouldn't display this error anymore to me. Okay, perfect. Let's clear this and run it again. All right. So what this does is we're calling the program, we're giving it the URL to the application, and we're giving it a SQL payload. And so it builds the request for us, it runs it, and then if it sees the product catgrin, it will return true, which will print out SQL injection is successful. If it doesn't see that product, that means we didn't display any unreleased products, and therefore it'll return false and run and print the command SQL injection unsuccessful. So this is a true case. In this case, it is successful. Now, if we run it again, but with I don't know, just a single quote, which should just display an internal server error, it should say SQL injection unsuccessful. Okay, perfect. So we've successfully completed the exercise. To recap, in this video, we first manually exploited a SQL flaw in the category filter field of the application. This allowed us to view products that have not yet been released to the public. We then scripted that exploit so that it automatically does that for us. I'll add the link to the exploit in GitHub in the description of the video.